Hi, I'm Jamie Ray, the NGAUS Aviation Task Force Chair and today's host of the NGAUS podcast. Joining us today is Keith Flail, Executive Vice President of Advanced Vertical Lift Systems at Bell Helicopter. Keith, welcome to the podcast.
Thanks, Jamie. Really appreciate the opportunity to spend some time with you today and talk about the latest of what's going on at Bell and our association that we've had with the Guard for years and years, with our rich history going back over the last 85 years. So thanks for having us.
Oh, please, our pleasure. And by any measure, Bell is a rotary wing industry leader and has been for generations. On the commercial side, Bell helicopters have provided solutions ranging from rush hour traffic reports to VIP and medical personnel transport to delivering critical workers to offshore oil rigs. On the military front, Bell's distinguished record of fielding helicopters dates back to the 1940s and includes some of the best known and most notable platforms in the Army's history. Starting with the H-13 Sioux, continuing in the Vietnam era, the H-1 Cobra, and an aircraft arguably more associated with that conflict than any other, the venerable UH-1 Huey, which I'm proud to say that I once flew, and continuing to the present day with the modernized version of the Huey, the UH-1 Yankee, or twin-engine Huey, currently in operation with the Marines, and the V-22 Osprey, currently fielded to the Marines, Navy, and Air Force. Keith, please take a few minutes. Talk to us about the Bell aircraft that you've delivered over the years, particularly with a focus on the ones that you've delivered to the U.S. military.
Yeah, so we've had a great partnership with the military for years, and you look at Bell's rich history, again, going back over the last 85 plus years. We weren't the first helicopter, but Bell brought the helicopter mainstream when you look at everything that happened with air mobility in the Vietnam era. And now, as we're on the cusp of next generation tilt rotor with the V280, that's what we're looking at, is bringing the tilt rotor mainstream. There is tilt rotors within the Navy, within AFSOC for the Air Force, as well as with the Marine Corps.
Yes, there's certainly been pioneers and market leaders in that aspect.
Yeah. So as we look at where we've been and then where we're going, we're now at the point in terms of this rich history and what we've been able to do, how we've been able to change aviation, and what the focus areas have been. So taking all of that rich history and then looking forward in terms of Army modernization as an example, looking at the things that are happening at the future long-range assault aircraft, the future attack reconnaissance aircraft, and really where we now are as a nation in terms of wanting to retain that overmatch against our adversaries. What's next by taking that rich history and applying it to the future, being able to bring revolutionary capabilities that have that speed, that reach, but also really focused on the affordability and sustainability of these assets going forward.
Absolutely. Thank you, Keith. Yeah, and we're going to probably talk about that a little more, some of the attributes you just talked about. And it's been over more than 70 years that Bell's been in the rotary aviation game, or actually what you could talk about, 85. And if there's a constant, it's that the industry is dynamic and the capabilities continue to evolve. How has rotary wing aviation evolved over those 85 years? What are some of the lessons that Bell has learned, and how have you integrated those lessons that you've learned into the current products that you offer?
Yeah, great question. So in terms of lessons learned, being very air vehicle centric, obviously you have your typical key performance parameters that you're looking for an aircraft, speed, range, payload, endurance, all those things. But what we've really been able to get to now is you look at what's changed within the industry, the digital thread, what's out there that you can leverage when you start with everything in digital design, and you're able to use that data across the entire life cycle. So that's a big game changer in terms of how you fundamentally design the aircraft, which then impacts how you're going to build the aircraft, the planning, the assembly, the precision with which the parts go together. So a lot of things that we're able to do with a digital environment that show up with a lot of second and third order effects that are extremely positive in terms of the affordability and the cycle time with which you can do things to be much more responsive, just because you went from a 2D paper world into a 3D world. And then you look at how technology has advanced. You look at our aircraft, the V280 that we flew through the joint multi-role effort with the United States Army, which is kind of the precursor to the long-range assault aircraft program that's about to happen. That cycle of learning and previous cycles of learning we've had at Bell by having our teams in the 3D environment in terms of what we've been able to do in terms of the cycles that we've been able to turn, in terms of getting through the design process, getting parts on dock, building the aircraft, getting the aircraft tested, getting the aircraft into flight. You can just see all the cycle time reduction in terms of what that means. So you're able to do things much quicker, but you're able to do them affordably. And then another key piece is the sustainability. Those that are in the rotorcraft world understand that sometimes 50% of the maintenance is caused by 50% of the maintenance, or you may be taking perfectly good parts off of an aircraft. Well, now the technology allows us to understand much more about the health monitoring of the aircraft, where it's telling us when we need to do something.
Kind of more proactive as opposed to reactive.
Absolutely, maintenance. And being able to expand that maintenance-free operating period so that our warfighters are able to take these aircraft out into an austere environment and operate them with much greater op tempo.
Yeah, that's great to hear, because certainly as the battlefield continues to evolve and our target of who we might need to fight against, the being able to operate in that austere environment with higher operational op tempo, meaning we need our aircraft to be more flyable more often. That's great to hear. And without question, the biggest innovation of the last decade or so in rotor wing aviation has to do with the growth of what we in the military call unmanned aircraft systems and what the general public calls drones. So how does Bell see unmanned rotor wing aviation developing over the next 5 to 10 years? What are some of the platforms you've developed, and can you also talk to us about some of the programs that you have currently in development?
Yeah. First of all, related to unmanned, there's so much that's happening in that space right now. So from a pure technology standpoint, our aircraft are fly-by-wire aircraft. So being able to use that functionality, that triple redundant capability that's on the aircraft, and adding that additional loop of functionality to get to the autonomy, we were actually able to demonstrate that during the joint multi-role effort with the Army with V-280. So we actually had safety pilots on board. The aircraft flew autonomously. Aircraft came up to a hover, took off. It converted from helicopter mode to cruise mode, went and flew a pattern, several waypoints, came back, brought itself to a hover and landed itself on its own. So there's several levels of autonomy that are out there, and when we talk about unmanned assets, we're bringing capabilities that really provide that optionally manned capability, and really focused a lot on supervised autonomy. So really the cognitive offload that you can provide to the aviators, so that they're spending their time, fighting the mission and not having to do extraneous tasks that the aircraft can do on its own.
Exactly. Workload is something we always have to be careful that we manage for the pilot.
Yeah. So along that journey, with what we're bringing for our FLRAA offering, what we're bringing with our FARA offering, fly-by-wire aircraft, so that you can be manned, you can be unmanned, and provide that supervised autonomy capability, so that you have a much more efficient and safe crew in terms of where their focus is. A couple of things we have going on at Bell within our innovation group is we actually have a dedicated effort for platform agnostic autonomy, to be able to continue to develop this capability as you look at the various levels of what you want an autonomous platform to be able to do.
Great plug and play capability.
Absolutely. And then take those respective modules that you need and use them across a variety of platforms. We also have an autonomous pod transport that we've been showing out there to the community. We've participated in several warfighting experiments with several of the services. And what this really is you think of, kind of looks like a biplane. It's a tail sitter, and once it's a vertical lift aircraft, runway independent, and then it turns and it rides on the wing. And a scalable, flexible system, very inexpensive. And you really look at kind of a resupply capability of what that can provide at the different echelons of squad, platoon, and company level, and literally has a pod that is the carrying for the cargo. So is it water resupply? Is it ammunition? Is it food? You can hook rucksacks to it, so it could move from point A to point B to move that. So really excited about that when you look at the different things that are happening in the unmanned space and the scale at which you want to operate.
That's great. Sounds like it really kind of decreases our vulnerability, potential line of communication interruption, and as you said, it sounds like vertical capability, the ability to possibly get it to the point of need, the soldier, is increased dramatically.
Exactly, and then you look at what's happened over time in terms of the burden that's on the soldier, in terms of the amount of gear that they have to carry and what they're expected to do.
I'm glad I'm not a young man anymore.
Yeah, Yeah, I mean, me too. And it doesn't get any easier because there's more capabilities that come out, and that burden on the soldier and be able to offload that when they're executing missions so that they're able to have their gear or their resupply meet them where they need it to in a very efficient fashion.
Keith, thank you. And some of you've touched on or given me a pretty good segue to my next question with some of your prior answers, but to touch on specifically, the Army has identified 6 critical modernization efforts necessary to remain postured to prevail in future conflict against any peer or near-peer competitors, one being Future Vertical Lift or FVL. The Futures Command has identified 4 signature efforts or capability sets that need to be developed to address current identified aviation capability gaps. First of these is Future Attack Reconnaissance Aircraft, or FARA, and Bell has an aircraft as part of the competitive down select. For going on a decade now, the Army has not had a rotor wing aircraft whose primary exclusive mission has been dedicated to the scout or reconnaissance mission. The Future Attack Reconnaissance Aircraft will address that capability gap, and Bell's entry, as you know, is the 360 Invictus. Take a few moments, if you could, tell us about the 360 Invictus, how you developed it. Just give us an overview.
Yeah, so our Bell 360 Invictus is our offering for the Future Attack Reconnaissance Aircraft, as you mentioned. So my background is actually as a Kiowa Warrior guy. That's what I did when I was an active duty in the Army.
Pretty good fit
so it's pretty exciting to me to see the next generation of this coming together. That capability gap that the Army's been dealing with, they thought they could do without it. It's certainly a requirement for what you need to be able to do for those reconnaissance and security missions that are out there. So when we look at that capability and what's required and the Army modernization initiatives that you outlined, Bell is in the space for competing for the Future Attack Reconnaissance Aircraft and the Long Range Assault Aircraft. On the Future Attack Reconnaissance Aircraft side, looking at what is necessary there in terms of what the Army has to do in multi-domain operations, especially in that penetration phase, having an aircraft with that significant speed, in this case 180 knots, that you have to be able to execute during that part of the operation. How are you going to get to that capability and provide all the things you need within a reconnaissance and security system like our Invictus? We really focused on simplicity, so the elegance and simplicity of how you do that. So a lot of the things that we've looked at in terms of previous proven designs that we have on our aircraft, you first look at our 360 Invictus and it looks like a helicopter. However, a lot of the key features that it has is that low drag tandem cockpit in terms of all of the analysis we've been able to do to get all the drag that we can off of the aircraft. As you move back, you look at the rotor system, articulated rotor system, coupled with the lift shearing wing that you see on the aircraft. So what that provides is, as you get up to speed, significant portion of the aircraft is carried by that wing, and you're able to offload the rotor significantly. So it's a very efficient propulsor that gets you to that speed of 180 knots with only a 4-bladed rotor system. So when we talk about that, there's lots of different configurations that you can do to execute the mission, but when you look at the cost drivers downstream for rotorcraft, it's typically your blades and your gearboxes are the critical drivers. So the simplicity that we're able to put into the gearbox, into the transmission, as well as limiting the number of blades that you have on the aircraft, that you can couple that with the wing. Additionally, the way we've configured the aircraft, the wing and the structure of the wing is very synergistic with the integrated munitions launcher. So all those munitions that are carried in the belly of the aircraft, because you don't want them hanging out in the airstream with the kind of drag that's associated with that when you're trying to dash at 180 knots. So putting the weapons and the payloads out along that wing and that structure that the wing provides a very stable configuration for the weapon system to egress the weapons, fire, and then put them back inside the aircraft. So, and then continuing to move back the aircraft, we changed the tail rotor to an open tail rotor as we have greater understanding of the requirements. It's very high in the aircraft, so there's no safety issues, and that provides greater growth potential downstream. Because what we see with these aircraft is there's the first increment and what you need for capability in terms of advanced sensors and weapons and aircraft survivability equipment, and aircraft always gain weight over time. Yes. So we want to make sure that we're building in that growth potential so that as the Army has to continue to modify this aircraft throughout its life cycle, that it does have that growth potential. And then going back to the simplicity, being able to maintain this aircraft in a very austere environment and having a highly sustainable aircraft that is low risk and at the lowest price point in terms of the affordability that the Army has to meet, especially when you look at all of these things the Army's trying to do across these modernization lines of efforts. There's a big bill associated with that. So we want to provide that revolutionary capability that gives that increase in speed and reach and maneuverability for that reconnaissance mission, but without breaking the budget.
Okay, great, Keith. And you touched on not just some of the required attributes that were covered in the initial capabilities doc, but also a little bit about the desired. And specifically, you mentioned 180 knots, which is a requirement. There are some other challenges, or it seemed like unique engineering challenges you probably confronted in trying to develop the 360 Invictus. The 40-foot width requirement of the aircraft to include the rotor blade. You mentioned, or you touched on earlier about air-launched effects. And you also mentioned cost. So there was the requirement must be $30 million or less for the actual procurement, $4,200 for an operational hourly cost, and you mentioned weight, and you're correct. Every aircraft I've ever flown has gotten heavier with each iteration, and 14,000 pounds was the requirement there. So if you could touch on basically if any of the trade-offs that you had to encounter in designing that, but also the one piece which arguably is the biggest departure for equipment manufacturers you had to encounter is the modular open system approach, or MOSA architecture, and the requirement that the digital backbone of the FARA be MOSA inclusive. So could you talk a little bit about that?
Yeah, so great question. So when you look at what it takes to have a weapon system, truly, you need the air vehicle, you need the MOSA, and you need the mission systems. You have to have all of those components to truly create the weapon system. So when you look at some of these demonstrator aircraft and early prototypes, that's a very air vehicle centric focus. So as we move to the next stage and look at how we're going to implement modular open system architecture, we at Bell are providing a common open architecture digital backbone that we are instantiating both on our FLRAA and our FARA offerings.
And actually, so have you done that? Because this is historically a big departure for the industry. Have you done this already, or is this new ground for you, the MOSA, integrating the MOSA from the start?
So we've always had, if you think about MOSA, modular open system architecture, it's almost like the definition of it is it's like filling a glass with water. What level of MOSA do you have? Because there's a lot of initiatives that are out there, like the FACE efforts and other efforts that are across different services to get to that nirvana of open system architecture. Sure. So we are along that journey, but what we're doing now is providing the backbone, working with several companies in terms of how we're instantiating the modular open system architecture. So if you look at all the functional blocks that make up that architecture, having different companies provide the different systems that go in there, and giving the keys to the government, giving the intellectual property to the government, so they have the choice. Do they want to be the integrator? Do they want us to be the integrator? Do they want a third party to be the integrator? So I think a lot of what we're on related to MOSA is the proof points, prove it to me. So as we move forward, that's exactly what it's going to be, is the government has done a really good job providing use cases. If you can show me how are you going to integrate these new capabilities, how are you going to address obsolescence downstream and do it in an affordable fashion? And it's got to be, we got to be able to do much better than we've done in the past, because it just hasn't worked out the way the customer needs it. So within our digital backbone lab, that's where we're able to show and prove out a lot of those use cases, being able to literally have two different sensors in there, and when you want to change from one sensor to another, or your EGI within the aircraft, you want to change it out, being able to show that we can do that, run a simple config file, and be able to show that it can recognize the new system. So a lot of it is the how you're going to do it is by providing that proof. So that's really where our focus is, so that you literally have an air vehicle, and it's kind of analogous to like a PC that has a bunch of USB ports in it. That's the way the aircraft needs to be, because the Army's going to need to bring in some countermeasure to some threat that doesn't even exist yet, that we haven't even invented a countermeasure for. So you have to have an agile system that can handle that, where you can still bifurcate mission critical capabilities from the safety critical in terms of the flight controls aspect of the aircraft. So that's the journey that we're on right now, and we're very excited about it in terms of some of the open system verification demos and other things are downstream where the government will bring in third parties to actually look and see how did you all do in terms of providing us what we're looking for in that open system. So I think that's a critical piece. And especially on the FARA with the Bell 360 Invictus, it's a much more mission system intensive aircraft just because of the mission it does than a long range assault aircraft. But being able to show two different backbones that are the same backbone on two different aircraft, but you're still getting where you need to be in terms of adding those capabilities, changing out components, being able to bring in third parties that can play in that space, and still having the cyber protection at the end of the day.
So security is obviously a bit of a consideration whenever we go down that road, and it's got to always probably be at the forefront of your everything design. Yeah, it's good. Thank you. And you certainly covered of all the required attributes, and there are also a few others that were considered desired or preferred as part of the initial capabilities requirements document for FARA. A few of them being a minimum combat radius. Another big one being that it must have a minimum payload that's configurable with mission equipment package or armaments. And you briefly touched on it earlier, optionally manned. That's probably the biggest departure for rotary wing, historic rotary wing aviation type. So talk to me a little bit about how the 360 Invictus attacked those and how successful were you in trying to, with this great platform, integrate those capabilities as well.
Yeah, great question. So when you look at, the key attributes for any rotorcraft, you're typically looking at speed and range and payload and endurance. So for the FARA mission, being able to execute at 180 knots for a helicopter and us being able to show that, it's really going to shock people that the speed that the aircraft has within it. But when you look at stacking those requirements of that speed, the mission radius of 135 nautical miles, the payload requirement and the endurance requirement, what we're going to be able to do with the competitive prototype effort and how well do we inform those requirements for what the actual weapon system will be. I think the Army did a great job in terms of the playbook looks very similar to the way that FLRAA is laying out. So you had a joint multi-role effort as a precursor to FLRAA. Now the Army's gotten to the next cycle of learning, so they've tightened that schedule to say, okay, we're going to do a competitive prototype on FARA, and that will inform what are the final requirements that you can have for the engineering and manufacturing development system, and which will be the fielded combat aircraft. So, what we're actually able to do within industry when we demonstrate this in flight test. Right now for us, we're on the cusp of this very challenging stacked set of requirements when you look at where it is. But what better way to prove it out? The Chief Staff of the Army has referred to it several times that we're going to fly before we buy. So being able to get these assets into flight test, see what we can actually do. What are we able to execute? A lot of our analysis shows again that we're right on the cusp of being able to meet all of these stacked requirements. But to your point, from a weight standpoint, going very quickly with the competitive prototype, not really able to optimize in all the areas that you would like to in terms of weight, just because of what happens with the design iterations. Exactly. But because of what we're experiencing right now in the CP, we have another team that's looking at the weapon system. So as that learning is happening, here's the things that we can do on the weapon system. Here's the weight reduction initiatives of how we're going to get weight out. Here's other things that we can do for the weapon system as we learn through this prototype process. So it's it's been a exciting, very, very fast-paced program, but meeting our commitments, in terms of the Army throwing down a pretty sporty schedule and a challenging set of requirements. I think when you look across all the modernization initiatives, this really is what they're looking for in terms of this fly before you buy concept, both with FARA and FLRAA.
Sure, absolutely, Keith. Well, thank you, Keith, for joining us today. And this is what is part of our initial or our early stages, nascent stages. We hope be a continuing series of NGAUS podcasts here discussing specifically FVL. I found your answers enlightening, and I hope our NGAUS members as well as the general public do as well. And best of luck to you and Bell.
Yeah, thanks, Jamie. I really appreciate the time with you all today, and look forward to doing it again.
All right, thanks.